The year 1945, a testing ground in England. A shell weighing nearly 15 kilograms flies out of the barrel at a monstrous speed of 880 meters per second. The target is a captured German Panther, one of the most formidable tanks of World War II. The shell enters the frontal armor, pierces the entire hull through, and exits from the other side. British engineers exchange glances. Their creation works. The only problem is that it no longer has anyone to fight. Thus, the Tortoise was born, the heaviest and most useless British tank in history. 78 tons of armor, a crew of 7, a gun capable of smashing concrete fortifications into rubble, and a complete zero in its record of actual application. But to understand why the British even took on this monster, we must go back 5 years to the darkest days of World War II. Summer 1940. France is defeated in 6 weeks. The British Expeditionary Force barely escaped from Dunkirk, abandoning almost all their equipment on the beaches. The Luftwaffe is methodically bombing English cities. A German invasion of the island seems a matter of the coming months. But even at this moment, when the very existence of Britain hangs by a thread, the War Office is already thinking about a counter-offensive. Because it is one thing to fight off an invasion, and quite another to defeat Germany, and you can only defeat it on its own territory. And here the main problem arises. On the way to Germany stands the Siegfried Line, 630 kilometers of fortifications from the Dutch border to Switzerland. 18,000 concrete bunkers, anti-tank ditches, dragon's teeth, and minefields. The Germans had been building this line since 1936, and by the start of the war, it represented a real engineering nightmare for any attacker. Ordinary tanks are useless here. Their guns will not penetrate meter-thick concrete walls, and their armor will not withstand the fire of anti-tank guns positioned in fortified emplacements. The British needed a completely new type of machine, not just a tank, but a heavy assault tank. A machine that could approach an enemy bunker under heavy fire, withstand a hit, and methodically shoot the fortification to pieces with its gun. Speed is not important for such a machine, as it will support infantry that itself moves no faster than 5 kilometers per hour. The main things are armor capable of taking a hit at point-blank range and a gun capable of crushing concrete. The first attempt was a project with the simple name TOG, which stood for the Old Gang. The name was not accidental. The development was handled by veterans of tank construction who had created the very first combat vehicles during World War I. They decided that to break through fortifications, they needed something similar to the French Char B, a heavy tank with powerful armor and a long hull to cross wide ditches. The TOG turned out to be truly unusual. It used an electric transmission where a gasoline engine rotates a generator, which then powers electric motors on the tracks. For the year 1940, this was a very bold decision, but the project constantly stalled due to technical problems. In parallel, engineers developed an improved version called TOG 2. The machine received a torsion bar suspension and modular armor that could be increased depending on the task. The tank looked promising and could well have gone into production. But then politics intervened. Duncan Sandys, financial secretary to the War Office and incidentally Churchill's son-in-law, disliked this project for some reason. He had his own favorite, and that favorite was called the Tortoise. But before the appearance of the Tortoise, the British managed to stumble over a few more hurdles. The A-38 Valiant tank was created with a noble goal: maximum armor with minimum weight. Engineers decided to achieve this in a radical way, by making the machine as compact as possible. The hull literally wrapped around the internal components. There was almost no room left for the crew. The turret overhung the sides. The driver sat hunched in a fetal position. During trials in 1945, this machine broke down after a pathetic 20 kilometers of travel. Moreover, the driver almost received serious injuries from his own controls. The Valiant is deservedly considered one of the worst British tanks in history. There was also an attempt to create an assault tank together with the Americans. The project was called the T-14 and featured a machine with 133 millimeters of sloped armor and a cast turret. The Americans built prototypes, and the British looked forward to the results. It was planned to produce 8,500 such tanks. However, development dragged on so long that the first prototype arrived in England only in 1944, when the concept of the assault tank already seemed obsolete. The project was closed in December of that year. All this time, engineers at the Nuffield Company were working on their own project. April 1943. The War Office, together with the Ministry of Supply, issues a memorandum describing a new machine for breaking through fortifications. The requirements sound vague. A tank with very thick armor, a powerful gun, and the ability to overcome obstacles is needed. There are almost no specific figures because no one really understands what exactly this machine should be. The only thing clear is that it must be better than anything created before. The order goes to Nuffield Mechanization and Aero, and true madness begins. Over the next 10 months, from May 43 to February 44, engineers create 18 completely different projects. Each time they present a new version, the ministry changes the requirements. More armor is needed, a different gun is needed, a different layout is needed, and each subsequent project becomes heavier and more massive than the previous one. The problem was that the military themselves did not know what they wanted. The Siegfried Line loomed somewhere in a misty future, and the specific conditions for storming it remained a mystery. How many meters of concrete would have to be pierced? From what distance would German anti-tank guns fire? What width of ditches would have to be crossed? There were no answers to all these questions, so engineers had to build in maximum parameters in all directions, which meant a constant growth in mass. In February 1944, the final version was finally approved. The machine received the index A39 and the name Tortoise. The name turned out to be prophetic, but more on that later. The main design decision was to abandon the turret. Instead, the tank received a massive fixed casemate-type cabin. This design allowed for the installation of the thickest possible armor without weak spots like a turret ring or gaps between the turret and the hull. The frontal hull armor reached 228 millimeters, and the front of the cabin was a staggering 279 millimeters. For comparison, the German Tiger had 100 millimeters at the front, and the famous King Tiger had 150. The British were creating a machine that, theoretically, no serial German gun of that time could penetrate. The hull sides were thinner, at 152 millimeters. However, the cabin sides had the same 228 millimeters, providing protection with a huge margin. All this armor was a single cast structure of armored steel, a literal steel bell inside which a crew of 7 was sheltered. 7 people is a lot for a tank, but the Tortoise had good reasons for such a numerous crew. First, the driver and his assistant. Managing a 78-ton machine is no easy task, and these two were fully occupied with just driving. Second, the commander, who coordinated the actions of the entire crew and observed the battlefield through 7 vision blocks in his commander's cupola. Third, the gunner working with the main gun, which required 2 loaders because the ammunition was separate loading. First the shell, then the powder charge in a casing. The remaining 2 crew members served the machine guns. Now for the main caliber. The Tortoise was armed with a gun officially called the Ordnance Quick-Firing 32-pounder. This was a modified version of a 94mm anti-aircraft gun. It was originally developed as a replacement for the famous 17-pounder, which handled German tanks well, but was weak against concrete fortifications. The 32-pounder solved this problem in excess. The shell for this gun weighed just under 15 kilograms and left the barrel at a speed of 880 meters per second. Upon hitting a concrete bunker, it caused catastrophic destruction. But even more importantly, this gun turned out to be incredibly accurate. A gunner could hit a specific embrasure of an enemy fortification from a distance of a kilometer or even more. Such accuracy turned the Tortoise not just into a ram for breaking through defenses, but into a sniper rifle on tracks. The gun was mounted in a ball mount that allowed it to be aimed 20 degrees left and right, as well as raised 20 degrees up and lowered 10 degrees down. For a machine designed to fire at fixed targets, this was more than enough. The sight was located to the right of the gun and protected by a massive armored collar. For self-defense, the tank carried 5 7.92mm Bisa machine guns. One was located in the ball mount to the left of the main gun, and 2 more twin machine guns were in a small turret on the right side of the cabin roof. The twin machine gun had 2 barrels and could create a dense curtain of fire against enemy infantry. Some believed the right machine gun mount was intended for anti-aircraft fire, but this is unlikely. The view from it was too limited, and the horizontal aiming speed too slow for shooting at aircraft. The heart of the machine was the Rolls-Royce Meteor engine. A legendary tank motor, it was a simplified version of the Merlin aircraft engine. The same Merlin that lifted Spitfires into the sky during the Battle of Britain was now to push the steel giant forward. In the tank version, the engine developed 600 horsepower. In the Cromwell and Comet, this motor worked wonders, accelerating the machines to 60 kilometers per hour. But the Tortoise weighed 3 times as much, and here the Meteor had to work at the limit of its capabilities. In December 1944, the War Office placed an order for 25 pre-series machines. The completion date was set for September 1945. There was less than 6 months left until the end of the war in Europe, but no one knew that yet. 600 horsepower sounds impressive, but everything is relative. There is a concept called specific power, the ratio of engine power to the mass of the machine. It is this indicator that determines how mobile and lively a tank will be. For the Comet, which weighed 32 tons and was equipped with the same Meteor, the specific power was 18 horsepower per ton. This allowed the machine to accelerate to 64 kilometers per hour, though for the sake of preserving the tracks and suspension, the speed was artificially limited to 51 kilometers per hour. For the Tortoise, the situation was fundamentally different. The same 600 horses for 78 tons gave a specific power of only 7 horsepower per ton. The difference was nearly 3 times, and it was felt in everything. The maximum speed on the road was a pathetic 18 kilometers per hour. The speedometer in the driver's cab was marked up to 40 kilometers per hour, which seemed like an outright mockery of reality. The engineers apparently remained optimistic until the very end. On cross-country terrain, things were even worse. The massive side skirts protecting the suspension hung so low they almost touched the ground. Any attempt to overcome a serious obstacle threatened to leave the machine hanging on these skirts, helplessly spinning its tracks in the air. For a tank created to cross anti-tank ditches and dragon's teeth, this was a serious problem. The wide 88-centimeter tracks distributed the monstrous weight well over the ground, but in doing so, they mercilessly destroyed road surfaces. Fuel consumption became a separate headache. 2 tanks held a total of 527 liters of gasoline. It seemed like a decent supply, but the Meteor, working at its limit, devoured fuel at a terrifying rate. On the low-quality military gasoline supplied to the troops, the cruising range was about 140 kilometers. It turned out to be nearly 5 liters per kilometer of travel. For comparison, a modern city bus consumes about 10 times less. But even if you ignored the speed and gluttony, a much more serious problem remained: how to deliver this monster to the battlefield at all. On its own, the Tortoise could travel no more than 150 kilometers before completely running out of fuel. For transportation over long distances, a tank transporter was required. The standard Diamond T tractors used by the British Army could tow loads up to 40 tons. For the Tortoise, 2 such tractors had to be coupled together, and even then, they worked at the edge of their capabilities. Rail transport turned out to be practically impossible. The machine's dimensions exceeded the standard rail profile, and the weight was too great for most platforms. Theoretically, special transporters could have been manufactured, but the war left no time for such luxuries. Things were even worse with bridges. The British Army used pontoon and Bailey bridges that engineers could erect in a matter of hours. These bridges were designed for loads up to 40 tons. The Tortoise weighed nearly twice as much. This meant the machine could only move over permanent bridges capable of supporting such a mass. If a bridge was blown up by the enemy, the assault tank was useless until engineers could build an especially strong crossing. Building such a structure required time and special materials that might simply not be available in combat conditions. Inside the machine, despite its titanic dimensions, there was no sense of space. The breech of the huge gun occupied most of the fighting compartment. The vertical and horizontal aiming mechanisms were located under the breech, and the gunner worked in very cramped conditions. To the left of the gun was his workstation with the aiming hand wheels. To the right was the position of one of the machine gunners. The commander was located in the rear of the cabin, slightly higher than the other crew members. His cupola was equipped with a hatch and 7 vision blocks providing all-around visibility. At hand was an azimuth indicator showing where the main gun was currently pointed. 2 loaders worked in the center of the fighting compartment. Part of the ammunition was stored in racks along the sides where the shells lay. Powder charges were in special containers at the rear. The rest of the ammunition was located under the floor of the fighting compartment in special magazines. The driver sat in the front left in a separate compartment. In front of him were 2 control levers used to turn the machine by breaking one of the tracks. The gear lever allowed for the selection of one of 6 forward or 6 reverse speeds. The Merritt Brown gearbox was considered one of the best in its class and provided smooth enough control even for such a heavy machine. Gas, brake, and clutch pedals completed the controls. The instrument panel featured a speedometer, oil pressure and engine temperature gauges, as well as 2 fuel level sensors, one for each tank. A separate concern for the engineers was ventilation. 7 people in a confined steel space, a running engine, and powder gases after every shot created an unbearable atmosphere inside the tank. Exhaust fans were installed in the roof of the fighting compartment to solve this problem. The machine was also equipped with a small smoke mortar for laying smoke screens or giving signals. A total of 6 machines were built, and the internal layout on each of them differed slightly. Engineers experimented, trying to find the optimal arrangement of crew and ammunition storage. One of the machines bore a plate with the production date 1947. This meant that the tanks continued to be finished even after the war, although their combat fate had already been decided by then. Trials of the 32-pounder gun were conducted in strict secrecy. The British understood they had created something outstanding and wanted to confirm it in practice. For the test, a captured Panther was chosen, one of the best protected serial tanks in Germany. The frontal armor of this machine was 80 millimeters thick and positioned at a rational angle of 55 degrees from the vertical. This combination provided an effective thickness of over 140 millimeters and confidently held hits from most Allied guns at medium and long distances. The Tortoise was placed in a position 1,000 meters from the target. The gunner aimed carefully, and the gun spat out an armor-piercing shell with a protective and ballistic cap. The result exceeded all expectations. The shell did not just penetrate the frontal plate, it went through the entire tank and flew out the rear. The German machine, which had terrorized Allied troops from Kursk to the Ardennes, turned out to be defenseless against the new British gun. This was an important discovery. The 32-pounder was created for destroying concrete fortifications, not for fighting tanks. But trials showed that the machine was capable of destroying any German tank at distances considered absolutely safe for German armor. The gun's accuracy allowed it to hit specific vulnerable points on the target: vision slits, the gun mantlet, or the suspension. The Tortoise was turning not just into a siege engine, but into a universal fire support platform. According to the command's plan, Assault tanks were to be part of the 79th Armored Division under the command of Major General Percy Hobart. This division was a unique unit equipped with specialized engineering equipment, the so-called Hobart's Funnies. Mine-clearing tanks with flails, flame-throwing Churchills, bridge layers, and machines for crossing soft ground with carpet tracks. The 79th Division had an entire arsenal for breaking through fortified positions. The Tortoise fit perfectly into this concept. It was intended to suppress the firing points that interfered with the work of the engineering equipment. Imagine a situation. An engineering tank is trying to lay a bridge over an anti-tank ditch, and a machine gun is firing from a concrete bunker on the flank, mowing down the infantry cover. A normal tank cannot suppress this point. Its gun is not powerful enough against thick walls, and its armor will not withstand the return fire of anti-tank guns. The Tortoise solved this problem with one shot. 230 millimeters of frontal armor allowed it to approach the fortification closely, and a 32-pounder shell turned the bunker into a mass grave for its garrison. But while the British were making plans, the war was approaching its end. In June 44, the Allies landed in Normandy. By autumn, they had liberated France and Belgium, approaching the German border. Ahead loomed the Siegfried Line, the very goal for which the Tortoise was created. However, the reality turned out to be quite different from what the military strategists had imagined in 43. The fact was that the Germans had long stopped perceiving the Siegfried Line as a priority defense line. After the defeat of France in 1940, the fortifications became unnecessary. Why defend if the enemy is defeated? Heavy armament was dismantled and moved to the Atlantic Wall, which was supposed to protect Europe from a sea invasion. Garrisons were disbanded, and bunkers were partially disarmed. By 44, the fearsome line of defense was more of a psychological barrier than a real obstacle. When American troops approached the Siegfried Line in the autumn of 44, they found many fortifications were empty or armed with obsolete guns. The Germans hurriedly tried to restore the defense, but there was a catastrophic lack of time and resources. Allied aviation dominated the air, striking any attempts to reinforce the garrisons. Artillery methodically destroyed the concrete structures, which proved vulnerable under conditions of total firepower superiority. The breakthrough of the Siegfried Line occurred without the participation of heavy assault tanks. American infantry, supported by ordinary Shermans and self-propelled guns, punched holes in the defense. Engineering units blew up Dragon's Teeth and filled in ditches. Aviation knocked out the most stubborn pockets of resistance with 500-pound bombs. By March 45, the Western Allies had crossed the Rhine and rushed deep into Germany. The war was ending rapidly. In late April, Soviet troops began the storming of Berlin. On May 8th, Germany signed the capitulation, and the first Tortoise was still standing in the assembly shop, not ready for dispatch to the troops. The September deadline set for completing the pre-series batch had lost all meaning. The machines intended for crushing the Siegfried Line were 4 months late for the war. In the War Office, priorities were urgently reassessed. The world was entering a new era, the era of the Cold War and nuclear weapons. Cumbersome assault tanks created for breaking through static defenses looked like an anachronism. The future belonged to maneuverable forces capable of moving quickly across the continent and delivering swift strikes. The concept of the heavy assault tank died before it could be born. The 25 ordered machines were never finished. Instead, they limited themselves to 6 pre-series prototypes used exclusively for trials and experiments. Each of these machines had individual differences. Engineers continued to seek optimal solutions for a design that would never go into battle. 6 steel giants stood in hangars without any prospect of going to the front. The war was over, and the War Office faced an inevitable question: what to do with machines that were no longer needed? Maintaining each Tortoise was not cheap. The consumption of oil and fuel just for warming up the engines ate up a significant part of the budget. Furthermore, The equipment had to be serviced, guarded, and stored somewhere. In the conditions of the post-war economy, such expenses looked like an impermissible luxury. First, the machines were sent for comprehensive trials. Since the tanks were already built, it was necessary to extract maximum benefit from them for future developments. Engineers drove the Tortoise across testing grounds, studying the suspension behavior under extreme loads, checking the transmission on long climbs, measuring fuel consumption in various driving modes, and firing the gun while recording the recoil and its impact on the cabin structure. Every kilometer of travel and every shot provided valuable information for the designers working on the next generation of British armored vehicles. Of particular interest was the performance of the Meteor engine under peak load conditions. On the Tortoise, this motor worked much harder than on any other machine. Data on its wear, temperature conditions, and fuel and oil consumption helped improve the power plant for the Centurion tank, which was just being launched into serial production at that time. In a sense, the Tortoise became a sacrifice in the name of progress. It was tortured in trials so that the next generation of tanks would be more reliable and advanced. By the end of the 40s, the trial program was generally completed. Engineers had squeezed everything they could out of the assault tanks. The question of disposal arose. Cutting machines with fully functioning components into scrap seemed wasteful, so a more practical application was found. Several Tortoises were sent to artillery ranges as targets. Their 200mm armor provided an ideal test for new anti-tank weapons. British weaponsmiths were developing recoilless rifles, heat ammunition, and the first guided missiles. All this had to be tested somewhere, and the old Tortoises were as suitable as could be. Shells and rockets crashed into the cast hulls, leaving impact craters on the armor. Engineers studied the penetrations, evaluated the power of new munitions, and made adjustments to designs. Thus, machines created to crush German defenses served as targets for refining British weapons. Other specimens were simply dismantled for parts. Meteor engines were standardized with Centurion power plants, so individual units could certainly come in handy. Merritt-Brown transmissions were also valuable for repair units. Gradually, the assault tanks turned into donors for more successful machines continuing their service in the British Army. The exact number of destroyed and dismantled machines is difficult to establish. The documentation from those years is not fully preserved. It is only known that by the early 70s, most of the machines had been destroyed. One Tortoise without a gun still lies on the former military training ground at Kirkcudbright in Scotland. Another was shot up at the Lulworth Range in Dorset in the early 70s. Perhaps it was kept intentionally as a historical specimen, or perhaps they simply didn't get around to the scrap cutter. Either way, this machine escaped the fate of its siblings and survived to our day. The only fully preserved Tortoise today is in the Tank Museum in Bovington. It is one of the largest collections of armored vehicles in the world, where machines are gathered from the first rhomboid tanks of World War I to modern combat systems. The Tortoise occupies a place of honor among the exhibits. It is hard not to notice the 78-ton giant towering over neighboring machines. Remarkably, a red triangle remains on this tank's armor, a special marking meaning that the machine is a pre-series prototype and has not undergone the full armor plating cycle. In essence, it is an unprotected prototype, although even its armor is impressive in thickness. Serial machines, if built, would have received even more powerful protection. The last time the Tortoise engine was started was at the Tankfest Festival in 2011. The Meteor, which by that point was over 60 years old, was still capable of working. The roar of the 12-cylinder aircraft motor echoed across the grounds, and the 78-ton behemoth slowly moved from its place. Spectators gathered at the festival could see for themselves how slow this steel giant was. The turtle that was late for its own war made its last march before the public. Today, the Tortoise stands silently. Its gun is aimed at a void. 7 ghostly crew members will never lead it into a real attack. 230 millimeters of armor will never take the hit of an enemy shell. The 32-pounder gun, capable of piercing through any tank of World War II, is forever silent. This steel dinosaur remains a monument to an era when engineers believed any problem could be solved by adding more armor and more power. Sometimes they were right, but history decided otherwise. 6 machines, 25 failed orders, 4 months late. Such is the arithmetic of the Tortoise Project, the heaviest British tank in history, created for a war that ended without it, an ideal weapon against an enemy that had already surrendered, a turtle that never caught up with its goal.